Let's look at some problems on vector addition. Problem number 1. Let ABC be a triangle and let S be its circumcenter, O be its orthocenter, then SA plus SB plus SC is equal to, first option 4 into SO, second option 3 into SO, third option 2 into SO vector, and fourth option being SO. Now the solution goes like this. ABC is a triangle. O is the orthocenter given. Orthocenter is the point of intersection of altitudes. So O is the orthocenter. Let us say that D is the midpoint of BC. S will be on the perpendicular bisector of every side. So this is S, let us say. You join up A and D and also SO. It says this point of intersection will be G, the centroid. OG is to GS is 2:1. Now if you observe carefully, this triangle AOG, the triangle AOG is similar to the triangle SDG, and AO by SD will be equal to 2:1, and that will be equal to HG by OG by GS, and that we know is 2:1. So we make use of this result. Let us say there is one result that we need to use here on the section formula. Result on the section formula. Suppose you have a point P and you have two points on the line A and B. There is a point C which divides AB in the ratio m is to n. Then m plus n into PC vector is given by m into AC, m into PA plus n into PB. This is a section formula. All right, as a consequence of section formula you get this. Now let's make use of this here. Now we can write D is the midpoint of BC, BD is same as DC. This is A by 2 and this is also A by 2. We generally denote small a to be the side opposite to the triangle, opposite to the vertex A in a triangle ABC. So we have A by 2 here. Now what is it? You can say that D divides BC in the ratio 1:1. Now SD can be written as 2 into SD can be written as SD vector can be written as SB plus SC. Let us add SA both sides. SA plus SB plus SC will be equal to SA plus 2 times of SD. Okay, but one more thing that we need to know, that your AO is nothing but 2 times of SD. AO is a vector, SD. They're both in the same direction, and AO magnitude is 2 times the magnitude of SD. So AO vector is equal to 2 into SD vector. So this vector 2 into SD vector can be replaced by AO vector. Therefore, what do we have? Left hand side is SA plus AO. That is the left hand side. What about the right hand side? The right hand side I am not altering at all. SA plus SB plus SC. So what do we have? SA plus AO by vector addition, we know that it's equal to SO. So SO is equal to SA plus SB plus SC. So this is clearly appearing in the option 4. Option 4 is the right answer. Let's move on to the question number 2. Let ABCDEF be a regular hexagon and vector AB is equal to A bar and vector BC is equal to B bar, vector CD is equal to C bar. Then the vector AE is equal to, first option A bar plus B bar plus C bar, second option B bar plus C bar, third option A bar plus B bar, fourth option A bar plus C bar. Let's have a look at it. A regular hexagon ABCDEF, let's name it like this, ABCDEF. What are we given? AB vector is equal to A bar, BC vector is equal to B bar, and CD vector is given to be C bar. Now we need to find out the vector AE. This is the vector that we have to find out, AE. Now, okay, how can we get AE vector? AE vector, by addition of vectors, we can write that as AF plus FE. AE vector can be obtained by AF plus FE. But what is FE? This is parallel to BC and it is in the same magnitude. So we can say FE is nothing but B bar. So FE is B bar. What about AF? AF vector, as you see, is actually parallel to CD vector. AF vector is parallel to CD vector. And it is in the same magnitude as that of this. It's a regular hexagon, all the sides are equal, magnitudes are same. So we have AF vector to be same as CD vector. Therefore, we can write this CD vector. What is CD vector? C bar. Therefore, we have C bar plus B bar. It's clearly option 2. Option 2 is the right answer. Question number 3. In a triangle ABC, if A is origin and B is 3, 3 root 3, C is equal to minus 3 root 3, 3, then the vector of magnitude 2 root 2 units directed along AO, where O is the circumcenter of the triangle ABC is. First option, 1 minus root 3 times I bar plus 1 plus root 3 times J bar. Second option, root 3 I cap plus 2 J cap. Third option, I cap minus root 3 J cap. And fourth option, I plus 2J. Okay, let's have a look at the solution here. We observe that A is origin, B is 3, 3 root 3, and C is minus 3 root 3, 3. Clearly from the observation, if you look at AB, magnitude of AB, that is 3 square plus 3 root 3 square under root. What about the magnitude of AC? It's also the same. So magnitude of AB is same as, clearly AB's magnitude is equal to magnitude of AC. So the triangle ABC is an isosceles triangle. It's clear that it's an isosceles triangle. What about the vector AB bar dot product with AC bar? Observe that. What is the AB vector? That is 3i plus 3 root 3 jk. 3 root 3 j. And now the dot product with minus 3 root 3 I cap plus 3j cap. This will be equal to, this is clearly 0. When is the dot product of two vectors 0? When the vectors are perpendicular. So AB is perpendicular to AC. So A, we have a situation like this, B and then AC. So A is origin, it's in fact a right angled isosceles triangle. These two sides are equal. In a right angled triangle, we know that the circumcenter is given by the midpoint of the hypotenuse. So O has to be this. Circumcenter is the midpoint of the hypotenuse in a right angled triangle. Therefore, we have this thing. So clearly what you want is a vector along AO, which is O is the midpoint of it, and which will be of magnitude 2 root 2 units. So how do I write the vector? What are the Persian vector at the point B? 3 comma 3 root 3. And what about here? This will be minus 3 root 3 comma 3. Clearly this will be a bisector as well, bisector of this angle, as well as we can even say this is the midpoint, O is the midpoint. So we will just join up, find out this point, that is 3 minus 3 root 3 by 2, and here we have 3 root 3 plus 3 by 2. Okay, so what is a vector? What is this vector AO? We can say AO vector is given by 3 by 2 into 1 minus root 3 times I cap plus 1 plus root 3 times j cap. So we wanted a vector. Now observe that we wanted a vector along AO which is of the magnitude 2 root 2 units. So it has to be lambda times AO, and the magnitude of that lambda times AO should be equal to 2 root 2. Clearly we can observe that the only option that is clear observed is the first option. First option tells us it is a vector along AO, and clearly its magnitude is equal to 2 root 2. So we can go for the first option. Option 1 is the right answer. If the vectors 4i minus j minus 2k comma I plus 5j minus 3k and 3i minus lambda j plus k form a triangle, then lambda is equal to the first option 6, second option minus 6, third option 12, and fourth option minus 1. If the three vectors form the triangle, now three vectors can be forming a triangle if sum of any two vectors is equal to the third vector. Let us see, therefore, here we have here 4i minus 7j minus 2k and I plus 5j minus 3k. Let us call this some vector A bar, B bar, and let us say C bar is equal to 3i minus lambda j plus k cap. Observe that if you, the I component, if you observe 3 plus 1 is equal to 4 there. So it is appearing that B bar plus C bar may be equal to A bar. So this is B bar and that is C bar, and that is equal to your A bar. This is A bar. Alright, B bar plus C bar is equal to A bar vector. So that is what we observe here. So what do you observe? That 5 minus lambda, 5 plus of minus lambda should be equal to minus 7. So lambda should be equal to 5 plus 7, that is 12. So this is a possible answer. So lambda has to be 12. Option 3 is the right answer. Option 3 is the right answer. So let us move on to the next question, the question number 5. The incenter of the triangle formed by the points I plus j plus k, 4i plus j plus k and 4i plus 5j plus k is, first option I plus j plus k by 3, second option I plus 2j plus 3k. Third option 3i plus 2j plus k. And fourth option I plus j plus k. Now, we are given the position vectors of the 3 points which are forming the vertices of the triangle. What is that? The position vector of this is I plus j plus k. In other words, if you want to represent it in the Cartesian form, it is 1 1 1, 4i plus j plus k, that is 4 comma 1 comma 1 is the point corresponding to it. And what about C? We are given 4i plus 5j plus k. Now, the incenter I, position vector of the incenter is given by BC into A bar. A bar is the position vector of A plus CA into magnitude of CA into the position vector of the opposite vertex plus AB into magnitude of AB into C vector divided by magnitude of BC plus magnitude of CA plus magnitude of AB. That is, you can write the sides. Now, observe that it's clearly this is a 4 units. They are only differing in the I coordinate, x coordinate, and this displacement is 3 units. And what do we have observe here? 4i plus k and then 4i plus 5j plus k. This is 4 comma 5 comma 1 here. So, the x component and y component are one and the same there. The difference of the y components, that is clearly 4 units. And you also observe that this is 4 minus 1 whole square, that is 3 square plus 4 square under root, that is 5 units. So, 3, 4, 5, they actually form a right angle triangle here. Okay. So, B will be this angle would be actually 90. Anyway, that's of not much of use to us. Here, we just need to write the position vector of I here. I have everything now. 3 into 4i plus 5j plus k. We can write that. What is the magnitude of BC? 4 units. So, 4 into I plus j plus k plus 5 into 4i plus j plus k plus 3 into 4i plus 5j plus k, the whole thing divided by 4 plus 5 plus 3, that is 12. So, and that is clear that what do you get here? 4 plus 20, 24 plus 12, 36. So, 36i by 12, so that gives us 3i, and it is clear to observe that j component will be 2 and then k, 3i plus 2j plus k. Option 3 is the right answer. Option 3 is the right answer. Let us move on to the next question, question number 6. If 4i plus 7j plus 8k, comma, 2i plus 3j plus 4k, comma, 2i plus 5j plus 7k are the position vectors of the vertices AB and C respectively of the triangle ABC. The position vector of the point where the bisector of the angle A meets BC is, first option 2 by 3 into minus 6i minus 8j minus 6k. Second option 2 by 3 into 6i plus 8j plus 6k. Third option 1/3 of 6i plus 13j plus 18k. Fourth option 2 into I plus j plus k. Let us have a look at this. Again, one of the properties of the triangles here. the bisector of the angle A divides the opposite side BC in the ratio of the arms of this angle. That's the vertical bisector theorem. Now what is A? 4, 7. I am writing it in the coordinates form. 4, 7, 8. And B is 2, 3, 4. And the point C is given by 2, 5, 7. What is the magnitude of AB? What's the magnitude of AB? We observe that AB magnitude is 4 minus 2 whole square, that is 2 square, plus 7 minus 3 whole square, 4 square, plus again 8 minus 4 whole square, 4 square. That is under root of it. So 16 plus 16, 32, plus 4, 36. That makes it 6 here. What about the magnitude of AC? Let's look at the magnitude of AC. Observe that it is 2 square plus 2 square plus 1 square, and that's clearly 3 units. So this is 6 units and this is 3 units. It divides in the ratio 2:1. 6 is to 3. So BD, let us say the point where the angular bisector of the angle A meets the BC line is D. So that point is given by the point which divides BC in the ratio 2:1. That is 6:3 there. Okay, so I need to just find out the point D using the section formula. So what do we have here? 2 into 2. So position vector of D, let me write it, 2 into 2 plus 1 into 2 by 3, comma, that is 4 plus 2, 6, 6 by 3, that's 2. And then we have here 2 into 5, 10, 10 plus 3, 13, 13 by 3, comma, 2 into 7, 14, 14 plus 4, 18, 18 by 3, what you have here. This is 4 plus 2, 6 by 3, so this is 6 by 3, 1/3 of 6i plus 13j plus 18k. That's clearly appearing in the option 3. Option 3 is the right answer. Two forces act at a vertex A of the quadrilateral ABC represented by AB, AD vectors, and 2 at C represented by CD vector and CB vector. If E and F are the midpoints of AC and BD respectively, the segments AC and BD respectively, then the resultant is first option EF, second option 2 times EF, third option 3 by 2 times EF vector, and fourth option 4 times EF vector. You have a quadrilateral ABCD. It says the midpoint of AC is some E and the midpoint of DB is some F. Okay. Midpoint of AC is E and midpoint of, we have two forces, let us say F1 and F2 acting along AB and AD respectively, and we have two forces F3 and F4 acting along CB and CD here. Now what we wanted is the resultant, that is we wanted F1 plus F2 plus F3 plus F4. This is what you want. Resultant of 4 forces or resultant of 4 vectors or n number of vectors is just the sum of the vectors. Okay. So this is what we require here. Now observe that in terms of EF vector, that's what you want. You want this in terms of the EF vector. Let's see how we can do that. What is F1 plus F2? Observe that this F1 and F2 is AB and AD vectors. Okay. We know that F divides dB in the ratio 1:1. So what is this? This AF vector is 2 times of AF vector is your F1 plus F2. F1 plus F2 is equal to, again the section formula, we can use that, and 2 times of AF. Similarly, what about F3 plus F4? Again, let's consider this triangle CDB. F3 plus F4 will be equal to 2 times of CF. That is 2 times of CF. Observe that this AF part can be written as, I have to involve E and F now. So how do I involve E and F? AF can be written as, this vector AF can be written as AE plus EF. So AE plus EF. Similarly, what about CF vector? CF vector can also be represented in terms of CE plus EF. So let's add up now. Adding the two equations, what do we get? F1 plus F2 plus F3 plus F4 is equal to 2 times of AE plus CE plus 2 times of EF. Now, what do you know about these two vectors, AE vector and CE vector? They are in the opposite directions and they are of equal magnitude. We know that because E is the midpoint of AC, therefore AE in the magnitude y is the same as CE the magnitude. Therefore, what do we say? We can say that here they two cancel each other. So these are negatives of one another. The resultant will be 0. So what we have is 2 into 2 into EF, and that is equal to 4 EF. That's 4 times EF vector. It's 4 times EF vector, and the answer is 4. Answer is 4. Fourth option is the right answer. Let's move on to the next question. Question number 8. If the vector I plus 2xj cap plus 2k cap is rotated through an angle theta and doubled in its magnitude, then it becomes 2i cap plus 2x plus 2 into j cap plus 6x minus 2 into k cap. Then the values of x are, first option 1 comma 1 by 3, second option minus 1 comma 1 by 3, third option 1 comma minus 1 by 3, and fourth option somewhere x belongs to the open interval 0 comma 3. Now we are given a vector, let's say I cap plus 2xj cap and 2k cap. This is some vector like this. It's rotated through some angle theta, and now it's doubled. So what is it? This is theta here. Let us say this is our B bar vector. Clearly B bar magnitude is 2 times the magnitude of A. This is our vector A bar, and the vector B bar after rotation and magnifying 2 times is 2i cap plus 2x plus 2 into j cap plus 6x minus 2 into k cap. So clearly the magnitude of B has to be 2 times the magnitude of A here. So what is it I can say? Magnitude of B square has to be equal to 4 times the magnitude of A square. What is the magnitude of B square? 4 plus 2x plus 2 the whole square plus 6x minus 2 the whole square. And that should be equal to 1 square plus 2x square plus 2 square. What we have here? And what do we have here? So we get a quadratic in x, and solving for x we get the option to be, it's a quadratic equation in x, and solving for x here we get x to be 1 or minus 1 by 3. 1 or minus 1 by 3, therefore option 3 is the right answer. If a bar and b bar are two non-collinear vectors, then the points L1 a bar plus M1 b bar, comma, L2 a bar plus M2 b bar and L3 a bar plus M3 b bar are collinear if, first option, sigma of L1 into M2 minus M3 is equal to 0. Second option, sigma of L1 into M1 minus M3 is equal to 0. Third option, sigma of L1 into M1 plus M3 is 0. And fourth option, sigma of L1 into M2 plus M3 is equal to 0 here. Now a bar and b bar are non-collinear vectors. That means they're non-parallel. None of these vectors can be expressed as a linear combination of other vector. That is, you can't express b bar as lambda times a bar or a bar as lambda times b bar. So non-collinear vectors here. Non-collinear vectors are also linearly independent. So here we have L1 a bar plus M1 b bar. These are 3 points A, and the point whose position vector is L2 a bar plus M2 b bar, and C is L3 a bar plus M3 b bar. Now these 3 points are collinear. When are 3 points collinear? That means AB vector has to be equal to some lambda times AZ vector. Okay. So what is it I can say here? L1 minus L2 into A bar, or L2 minus L. How do I write AB vector? The position vector B minus position vector of A. So L2 minus L1 into A bar plus M2 minus M1 into B bar should have been equal to lambda times L3 minus L1 into A bar plus lambda times M3 minus M1 into B bar. When you have a linear combination of two non-collinear vectors, this is one linear combination, this is another linear combination of A bar and B bar. Because they are non-collinear vectors, the scalars, corresponding scalars can be equated. So L2 minus L1 is same as by L3 minus L1, I can say is equal to lambda, and that lambda is also equal to M2 minus M1 divided by M3 minus M1. So clearly, what do we get here? We will cross multiply here L2 minus L1 into M3 minus M1 is equal to L3 minus L1 into M2 minus M1. Now after grouping the terms properly, we will observe that if you observe here, we have here L1 into L1 is a common thing here. So we have here, we can observe that you will get L1 into M2 minus M3 plus L2 into M3 minus M1 plus L3 into M1 minus M2. After regrouping the terms and writing, we can rewrite this equation in this form, and that's clearly appearing in the option 1. So it is in the form of sigma of L1 into M2 minus M3 equal to 0. Let's move on to the next question, question number 10. Let A bar, B bar and C bar be three non-zero vectors, no two of which are collinear. If A bar plus 2B bar is collinear with C bar and B bar plus 3C bar is collinear with A bar, then A bar plus 2B bar plus 6C bar is equal to, first option, null vector, second option, lambda times A bar, third option, lambda times B bar, fourth option, lambda times C bar. Now, what are we given? A bar, B bar, C bar are such that no two of which are collinear. Okay. But A bar plus 2B bar, he says, is collinear with C bar. So that means it is some lambda times C bar. Similarly, we have B bar plus 3C bar to be equal to some mu times A bar, because that, he says, is collinear. If two vectors are collinear, one can be expressed as scalar multiple of other. So we have this thing. Now what we'll do is, we will eliminate B bar from these two. How do we do that? We'll multiply the second equation with 2. So 2B bar plus, so 2 here. And now subtract one from the other. What do we get? A bar minus 6C bar is equal to lambda C bar minus 2 mu times A bar, or plus of minus 2 mu into A bar. Now clearly we observe that we have 1 into A bar plus minus 6 into C bar and minus 2 mu into A bar, I will rewrite it this way, plus lambda times C bar. When we write a linear combination of two non-collinear vectors, some x1 A bar plus y1 C bar is equal to some x2 A bar plus y2 C bar. We can equate the like coefficients here, they just act like ij vectors. So we can write here 1 equals to minus 2 mu and minus 6 is equal to your lambda. I can substitute the value of lambda here. So what do we get? Therefore, A bar plus 2B bar is equal to minus 6C bar, which implies that A bar plus 2B bar plus 6C bar is equal to null vector. So clearly, A bar plus 2B bar plus 6C bar is equal to a null vector there. So option 1 is the right answer. Let's move on to the 11th question. Let f bar of t be equal to bracket of t into I cap minus fraction part of t into j cap plus bracket of t plus 1 into k cap, where bracket denotes the greatest integer function. If f bar of 5 by 4 and I cap plus lambda j cap plus mu k cap are parallel, then lambda and mu are. It's just a notation that we just need to observe. We have a vector function here. I can think that it is a time factor. So we have a bracket of t into I minus fraction part of t into j plus bracket of t plus 1 into k vector. What is f bar of 5 by 4? So bracket of 5 by 4 is 1i minus fraction part of 5 by 4 is 1 by 4. So 1 by 4 j and 5 by 4 plus 1, 9 by 4, bracket value is 2j, 2k cap. That is f bar of 5 by 4. And what else? You are given a vector I cap plus lambda j cap plus mu k cap. These two vectors are parallel. These two are parallel. When are two vectors parallel? The coefficients of the like components, the like components must be proportional. We already have here I components matching here. So they should match. J component on k component also should match. So lambda should be minus 1 by 4 and mu should be equal to 2. Clear? Clearly the option 2 is the right answer. Option 2 is the right answer. Question number 12. The equation to the altitude of the triangle formed by 1, 1, 1, 1, 2, 3, 2, minus 1, 1 through the point 1, 1, 1 is given the vector form. First option, r bar is equal to I plus j plus k plus t times of I minus 3j minus 2k. Second option, r bar equals to I plus j plus k plus t times of 3i plus j plus 2k. And third option, r bar is equal to I plus j plus k plus t times of I minus j plus 2k. And the fourth option, magnitude of r bar equals to 5. Well, let's have a look at this here. We have a triangle ABC. The coordinates of A are given as 1, 1, 1. Coordinates of B are given to be 1, 2, 3. The coordinates of C are given to be 2, minus 1, 1. We are asked to find out the equation of the vector equation of this altitude from A on to BC. Now, before going to this, let's observe one thing. How do I write the vector equation of a line? Now, what can fix a line? One point on the vector parallel to the line. So, if one point on the line and a vector parallel to the line are given, then we can fix the equation of the line. We can write the equation of the line. So, let's suppose that I am given one point A bar and I am given a vector B bar parallel to the line. Parallel to the line. If r bar is a position vector of any point on it, r bar minus A bar can be written as lambda times B bar. In other words, r bar can be written as A bar plus lambda times B bar. Lambda is some parameter there. As you keep changing the values of lambda, you get different points on the line. Okay. So, here in the options we are given the parametric value to be t there. Anyway, we know this point A, one point on the line AD is known to me. Okay. And what I require is a vector parallel to AD. But I know that this vector AD has to be perpendicular to, AD is perpendicular to BC. So, we can go from the options here. So, the line AD must have been in the form of r bar equals to the position vector. One of the points we know is I plus j plus k, that is playing the role of A bar there, plus some parameter t times the vector, okay, some xi plus yj plus zk, let us say, which is this along AD vector. This xi plus yj plus zk has to be parallel to AD vector, and therefore, it has to be perpendicular to BC vector. So, we can just check from the options which of the vectors will be perpendicular to your vector. What is that vector BC there? Let us write the BC vector. BC vector is I cap, that is the position vector of C minus position vector I cap minus 3j cap plus minus 2k cap. So, clearly we will observe that I minus j plus 2k, observe that I minus j plus 2k is perpendicular to this. So, this dot product of this is 0 here, 1 into 1 minus 1 into minus 3 plus 2 into minus 2, that comes out to be 0 there. So, we observe that this vector is perpendicular to BC vector. So, that must be along AD then. Therefore, we can write the vector form of the equation of the line AD to be r bar equal to I plus j plus k plus t times of this I minus j plus 2k. So, that is, I have here r bar equal to I plus j plus k plus t times of I minus j plus 2k. So, option 3 is the right answer.